At its core, structs are everywhere. You're always declaring structs, you're always using structs. Every time you're adding a new file, you're adding a new struct, because in Zig, as you'll see, files are structs. So we go through a lot from just declaring basic structs, using them, generic comp time stuff, namespaces, again, files as structs. And at the very end, we go through the memory layout of different types of structs, from a normal Zig struct to an external or C struct, and also a pack struct. So if any of that sounds exciting, make sure stay tuned, watch the video, code along. That's the best way to learn. And if you have any feedback, drop a comment. And if you enjoy, like, subscribe. All those things really help. But let's jump into the code. And as always, let's jump into the first example. So how do you write a basic struct? Well, you're just going to give it a name, and then you're going to use the struct keyword. And now we can start filling in details. So we have F32 and F32. So a vec2 such as it's an X and a Y. And now a struct is just a container of properties, of elements, of anything you want it to be. So you can structure your data in your programs to be exactly how you want. So that's how you declare a struct. And now to initialize one, you can just declare it like any variable, but this time it's going to be a vec2. And then you'll use .x, let's just say 1.0, and .y equals 2.0. So now we have initialize a vector. And yeah, so that's one way to do it. And now if, let's say, I'm just showing another way to do it is if you can infer the type on one side. So you don't have to write everything. So here we just infer the type on A, but in this case, we're inferring the type on the struct itself. Okay, now we can print A and B, and if we run that, we see 1, 2 for both of them, right? But let's say we want to actually change B, right? So we can make that a var instead of a const as normal, and then we do like b.x equals 10, and then b.y maybe minus equals 1. And now if we go to print them again, we see we made x 10, and then we subtracted 1, so 2 minus 1 is 1. And that is the basics of structs, right? Now let's get into default values. So again, this is just another struct that we declared. It's like, say we need a window struct, right? So we have its width, height, title, and is it resizable? We can see we gave all these defaults. So that means you can initialize a window without actually specifying any values inside. So before we had to do like .width, .height, and on all of them, right? But now with defaults, you can say if you don't specify anything, it'll just go to these values. But then also if you want to override some of them, so we can see like this is going to now have width of 1920 by 1080, but then the title will still be untitled and the resizable will still be true. And if we run this, we can see that. So this was the full default one. We can see those are the same values up here. And then this is where we override the 1920 by 1080, but then the other defaults stayed the same. And just as before, we could modify it to resizable, let's just say it's false. And if we run that one more time, we can see now it's false. And now let's look at a little bit more exciting examples. So now it's a vec3 instead of a vec2. And now let's say we want some methods on it. In other programming languages, you may see things like static versus not static. In Zig, the way you make something static is if you don't have self as the first argument, because all these functions are like syntactic sugar. If we look down here, we can see this method called syntax. So v.scale2 is the exact same thing as doing vec3.scale and passing in the instance with a value. So these two things are exactly the same. So if we look at up here, so scale, we pass in self. So we know we can use that syntactic sugar. But in this case, this is just like the namespace, right? So what do I mean by that? Well, we just have a vec3 namespace, and then in it is a function that we can call. And we look at that right here. So we use the vec3 namespace and then call the function on there. But if self, or like the struct itself, is the first value, you can call it with an instance. So like scale or add here. A common thing you'll see a lot in Zig is the @this, which is the exact same thing as writing vec3. So yeah, those two things are equivalent. If you prefer to just write vec3 over on everywhere, you totally can. It's just a stylistic thing. You have your option, and I'm just trying to show different ways you can do the same thing. And then if you need to, and a function that can mutate things, this needs to be a pointer. And again, I'll make a video on pointers very soon. And now let's really dive into this. So we call the init. So what it is it's like our constructor. So there's no like, in Python, you have the underscore init magic methods, but there's nothing magic or anything. In Zig, you have to do everything yourself. So this, we just wrote the init function right here. and it returns an instance of a vec3 based off these values. And now we can see we have a length, so we call that. And then, like I said, this one's mutable. So that's why v is var, because we need to be able to mutate it. If we made it const, this would fail to compile because this would break. And then sum, so we can see we're adding another vector to the current vector. And if we run this, the length of 5, and then after we scale it by 2, we get 680 because we start at 340. And then we sum it, we add 1 everywhere, and that's 791. So I briefly touched on namespaces in the previous section, but I just want to go a little bit deeper into that, what I mean. So another common use of structs is namespaces. So we can see we can define basically everything within a struct, and it's the exact same as if it was like top level, but now it's kind of in a namespace. So if you want to be able to access all this, you have to use that my math first, and then same circle area. If you want to be able to use these, you need to use the namespace. And while we're on namespaces, I also want to show how files can be namespaces. So something that people might do in other languages is you'll define your kind of namespace in another file like this. And then again, this is the exact same thing we just saw. So if we came back here and we got rid of this, how we'd access that is my math equals import my math.zig and then my math, right? So now we have the exact same thing. It's going to grab this struct and import it. And one thing I immediately took this from the other example, one thing you do need to do is make anything you want publicly available now that we're in a different file. That's another important part of namespaces. Once you get into separate files, that's when you need to start marking things public. And if we run this, we still get that pi and area, right? But then when we go to main, this can be a lot cleaner. So this is where I want to get into the next main talking point, is how every file is a struct itself. That's what I mean by this. If we just return the exact file itself, we see it's still a type. And it's just a type that has my math on it. So my math has the struct my math. So what can we do about this? So knowing the fact that files are structs themselves, head over to my math, we can just get rid of all this and just have everything top level, because it's still going to be wrapped in the struct itself when we go to import it. So now everything's working the same. And if we run it, it's the exact same output. And all that does is avoid us having to do the extra repetition of having the extra my math here. And just, it's a clean import that you can do once. Okay, and now we're going to briefly touch on anonymous structs and tuples. So what do I mean by anonymous struct? Well, we can just directly define a value. There's no actual definition. Like, we didn't define a vec2 and then use it here. We just said, hey, this value is an instance of an anonymous struct because it has no like parent name. That's why it's anonymous. There's no actual type that we've previously defined. We're just going to be inferred. And we know it has X and Y, so we can immediately access it. And if we run it, we can see 10 and 20 because that's what we've done here. And now things get a little bit more interesting when it comes to tuples. So we see we have what looks to be the exact same. It's an anonymous struct, but then the types are all different and there's no names, right? So that's the key difference, is with a struct, we name every value, but with a tuple, we don't have names, right? So then how do we access it? Well, you can access it just like an array. So we can just go 0, 1, 2 to get each of them. Then they'll have their own types. And we can see kind of with the hint here how the first one's a string, and then it's comp time int, then it's a bool. And again, if we look at that output, we see row zig 2026 and true. And then one kind of cool comp time feature, which again, comp time will be a video of its own pretty soon, but we can, and again, it has to be a comp time because we find the types out at compile time. So now we can do an inline for loop, which is a comp time for loop, and just like print the value for each of them. And then we can see field 0 is this, which is just the 3 character zig, right? Because we did any here. So any will just kind of specify to the simplest, which because there's no S specifier, it's going to print out the bytes instead of the string itself. But we do know that the string is zig. So if you just were to look at the 3 values, this would be zig. And yeah, 2026 and true. Okay, and now this is going to be one of the coolest examples, I'd say, and that's generics. So how does Zig do generics? Well, you can pass in a type and then return a struct that references that type. So then we can see this is going to be a very common pattern you see when you're in Zig for anything kind of generic that you want to do. This is what you're going to do. So you'll pass in a type. So in this example, we want an int pair. So we're going to pass in the type of i32, and it's going to create us a struct where, again, we're using the at this because we don't actually have a predefined type. So that's why this is so important and a lot more practical than the vec2 example. And then we have a first and second of this parent type. Then we can initialize it, and then just a simple method to swap first and second, right? So let's look at how this looks. What do we have? So we have an int pair, right? So now this int pair is a struct. It's a type, right? Because we returned a struct where all these values are now i32s. So now we initialize with 1 and 2, and then we swap it, and then something similar with strings. So we have a pair of const states, which again, are const u8s, which is just strings. So then we get a string pair with these two values, and then we can print first and second. So again, these will be swapped, these ones won't be. And if we run this, we get 2 and 1, Ziggy and Zeg. And then let's just say we wanted to swap it, and then it's mutable, so that needs to become a var, and run it, and then we get Zeg and Ziggy this time, same with 2 and 1. Now let's move on to our final example, and that's going to be a Zig struct versus an external struct versus a pack struct. So they all serve 3 different purposes, and this is more when the memory layouts are important, because all struct is a block of memory with all the different values inside of it. So let's look at a normal Zig struct. So Zig may reorder these fields based off what's kind of best at compile time. It can reorder them and look for speed and alignment, which you can go very deep into like memory representations and optimizations and all that. So definitely, if you're interested in that, something that low level, go check it out. Go do some more research about how different programming languages can reorder fields in a struct. And then let's look at an external struct. So if you ever worked in C, they will never reorder their structs. It's always going to be exactly how you type it. And that's exactly what we have with extern. The reason we have this is because a lot of time in Zig, you could be working with a language like C. And then in C, like I said, it doesn't reorder them. So in order to be able to interrupt and use FFI, you need to be able to have compatible structs with each other. So then if you know you're going to be like using one of your Zig structs with a C function or anything like that, any sort of FFI, then you need to use extern so that you're basically telling the compiler like, hey, leave this memory layout exactly as it is. Because again, this is all just memory. If the order's changed, that means as the struct gets read, the values in here will be different if they're reordered and the compiler wasn't expecting it. And then the last is a pack struct. So this one's pretty cool if you just need something in like this example of flags. Let's say you need just like a few different things that you know, but it doesn't need a lot of space, right? So you know it's a bool, and then mode could be 0 through 4, and then anything reserved, so could come in the future. Pack struct, instead of being like 1 byte, 2 bytes, 4 bytes, it's actually going to be bits. So all of this is only going to take 1 byte of memory, which is very cool. So yeah, so let's look at that. So let's look at the size of each of them, let's look. So 8, 12, and 1. So why are the first two different? Well, because Zig was able to properly reorder the struct to take exactly what it needs. So in this case, it's 8 bytes. But then C, because you kept it in this order, it's going to be different. So what exactly does Zig do? So you want the highest number of bits to be near the top. So what Zig's going to do, and we'll be able to see this directly. So remember, this was 12 bytes and this was 8 bytes. If we just change the order, we can now see they're both 8. So internally, Zig turned it into this. Yeah, turned a struct like this into a struct like this. But because we used extern, Zig wasn't able to reorder and then use less memory. Now let's get into this flags example. So then, yeah, so we have the ready, airbit, mode, reserved, and let's just print, if we print a couple of them, we can see ready's true, mode is 2. But then, yeah, we see the size of flags, it's 1 byte. So all of this kind of information and data is just taking 1 byte of memory. And yeah, I hope you enjoyed the video. I think there's a lot of good information in this one. I tried to keep things as concise as possible and go through the examples a bit faster and just leave more time for actually explaining stuff rather than you guys watching me type. Please let me know what you guys think about it. If you liked it, any feedback you have, please leave a comment. And yeah, if you did like it, make sure to like and subscribe. That really helps the channel, helps me grow, and indicates that you guys are enjoying it. And yeah, again, as always, there's Discord link down in the description if you want to come say hi and chat. But besides that, have a great day.